Hi everyone, very good morning. Today we are going to study about the question number 61. It's all about refraction through lens. So what is refraction through a lens? We need to understand. So here when you consider the very first thing what we have to understand is what is refraction through a spherical surface and what is the formula related to it. When you consider a spherical surface which is separating two media mu1 and mu2 and object is in medium 1 at a distance u and the corresponding image. So due to refraction the ray deviates and the image forms at one particular instant. It is not compulsory that always image forms in this manner only, but one particular case we are taking. So that one generalized formula we will derive that mu2 by v minus mu1 by u equal to mu2 minus mu1 by r, where u is object distance, v is image distance, and mu1 mu2 are object and other side media. You have to take always first object side. So object side you have to consider as mu1. Then the other side obviously you will take it as mu2 so that no confusion will come for you. And r is the radius of curvature. And you have to follow the proper sign convention like from the pole in the direction of incident light, the distances are positive, and in the opposite direction of light ray distances are negative, or simply to say object side is always negative, other side is positive. So if a image forms object side only, that is called virtual image. Other side means real image. So like that, you have to remember this formula and you have to follow the proper sign convention. So they can ask the kind of question based on this formula. Now using the same formula, you can understand how the refraction takes place through a lens. Now lens means a device for image formation or for magnifying image. Now there are two types of lens. This is convex lens and this is concave lens. This is biconvex lens, this is biconcave lens. Also plano convex lens and plano concave lens also will be there. But usually convex lens and concave lens, biconvex and biconcave lens, based on which they used to give the question. Now when you consider, see here, this is the lens. Now object is here. Now the object will go and it undergoes the refraction and the final image forms at somewhere. Like this is now object distance, this is now image distance, and this is called optical center. Now all the distances for every lens we measure from the optical center. Like in case of mirror pole, here optical center. Now when you consider this is the first surface, this is the second surface, first what happens is, see here, object is there. Now ray will go and it will undergo refraction and one ray refracts and it forms one virtual image. See, this one. This is the virtual image. Virtual image of first surface. Now for the second surface, this ray will act as object like this. Now this is I1 and here it undergoes the refraction. Then here it forms the final image. So that this I1 nothing but virtual image of first surface and virtual object of second surface, which is not forming outside, which is inside the media, like this media mu1 and this media mu2. So that here you can make the formulas like, see here, this is mu1, now this is mu2, this is mu2, this is mu1. Now the equations you can make like for this surface, see mu2 by V1. So this I1 distance you consider V1 minus mu1 by U equal to R2 minus R1. Sorry, just 1 second. Mu2 minus mu1 by R1. For the second surface, if you write it, now image is mu1. Mu1 by V minus mu2 by V1 object equal to now mu1 minus mu2 by R2. Now if you combine these two things, then you will get the equation mu1 by V minus mu1 by U equal to mu2 minus mu1 times 1 by R1 minus 1 by R2. So this is the formula for refraction through a lens. So that here if you take mu1 common, so 1 by V minus 1 by U equal to take mu1 this side, then mu2 by mu1 minus 1 times 1 by R1 minus 1 by R2. So this is the formula for refraction through a lens. Now you can understand what is the focal length of a lens and what is the and how it depends on the medium. Now when you consider if object is at infinity, then image forms at focal length. Then if you substitute the value 1 by f minus 1 by infinity equal to mu2 by mu1 minus 1 times 1 by r1 minus 1 by r2. That means the focal length is mu2 by mu1 minus 1 times 1 by r1 minus 1 by r2. Now here you have to understand that in case of convex lens, R1 is positive and R2 is always negative when you place an object in front of the lens. So that 1 by R1 minus 1 by R2 is positive. So 1 by R1 minus 1 by R2, what it will become? Positive. And in case of concave lens, it is reverse. That is R1 will become negative, R2 will become positive. So that 1 by R1 minus 1 by R2 will become what? Negative. So that in air, that is mu1 equal to 1. So focal length is positive for convex lens and negative for concave lens. But in any other medium, the focal length changes. As medium changes, focal length of lens also changes because the focal length of the lens is depending on refractive index of the medium. See, focal length of mirror independent of medium, but focal length of lens fully depending on the medium in which it is placed. And when mu1 is greater than mu2, then convex lens focal length will become negative and concave lens focal length will become positive. That means the convergent convex lens behaves as divergent lens and the divergent concave lens behaves as convergent lens. So that is the effect of medium on the focal length of a lens. Now here comes the formula that 1 by V minus 1 by U equal to what we got? Mu2 by mu1 minus 1 into 1 by R1 minus 1 by R2. But this is nothing but our 1 by focal length. This is the. So this is called lens maker's formula. Just like in case of mirror, 1 by V plus 1 by U equal to 1 by F. Here 1 by V minus 1 by U equal to 1 by F. And here also we have the formula for magnification. So what is the magnification is same kind of formula. Magnification equal to height of image by height of object, nothing but V by U. So similar kind of relations will come here also, and you can find the nature of the image. Like if magnification is positive or negative. If magnification is positive, then what you can conclude is it is erect image. Otherwise, we can take it as inverted. Now, V is positive means real here. V is negative means object side means virtual. But in case of mirror reverse, if image is forming object side, that is real, and the other side virtual. But here if the image is forming the other side of the lens, then it is real, otherwise it is virtual. And magnitude of magnification greater than 1 means enlarged image, less than 1 means diminished image. Now what are the image formation rules for lens? See, there are simple rules, like when ray coming parallel to principal axis after refraction passes through focus on other side, and vice versa. Vice versa means what? If the ray is coming passing through the focus of one side, then after refraction it becomes parallel to the principal axis on other side. And if ray passes through optical center, it goes undeviated. It goes undeviated. And if you want to take the object and image formation position, see, convex lens is same like concave mirror. Like object is at infinity, image forms at focus, but other side. So in case of mirror, same side it will form, but in case of lens, other side. And the position for concave lens is same like convex mirror. So if you understand and if you remember concave mirror and convex mirror, same thing you can apply here for concave and convex lens with a slight difference that their real means in front of the mirror object side. Here real means other side of the lens, that is other side of the object. That is the major difference. So their negative distances are real. Here positive distances are real. That is what you need to understand. Now let's take few examples based on whatever we have discussed. So it's all about refraction through a spherical surface, refraction through a lens, and the focal length of a lens and its dependence on medium, and the lens maker's formula and magnification produced by a lens. Now let's take the very first question. Locate the image of the point object O. The point C is center of curvature of the spherical surface. See here, the object is at minus 10 centimeter. Now image is forming at center of curvature, radius is, the other side means that will become plus 30 centimeter. Then they are asking position means V. Now the object side medium is 1, the other side is 4 by 3. Now it is a direct question. Mu2 by V minus mu1 by U equal to mu2 minus mu1 by R. Now with proper sign convention you substitute. That is 4 by 3 by V minus 1 by minus 10 equal to mu2 minus mu1. 4 by 3 minus 1 by R is plus 30. So that 4 by 3V equal to, this is minus of minus plus. If it goes that side plus, this is 4 by 3 minus 1 by 3. So 1 by 90 minus 1 by 10. So just try to solve it. So that it will become 10 minus 90 minus 80 by 900. So 0 cancel. So V value will become, cross multiply it, minus 4 into 90 by 3 into 8. So 4 2s are 330. So V equal to minus 15 centimeter. So minus 15 means what? The image is forming same side as that of object, virtual image. Like that you can conclude. Now similar kind of one more question, just try to understand. See, a glass sphere of radius r 10 centimeter. Now radius is 10 centimeter is kept inside water. A point object O is placed at 20 centimeter from A as shown in figure. Find the position and nature of the image when seen from other side of the sphere. Now here, first refraction takes place here. Where, see, first refraction you take. U is minus 20 and it is kept inside the water. So that mu1, that is here, now mu1. This is mu2. Now this is mu1. Mu1 is water. So that is 4 by 3. Now mu2 when you consider, that is 3 by 2. Now u, mu1, mu2 and radius of curvature. So now this is the curvature will become. So radius is the other side. So that is positive it will become. So plus 10. Now you substitute in the equation and you will get the V1 value. Now for the second refraction, you have to take this as object. Somewhere it will form. So accordingly you have to take V1. Now mu1 will become 3 by 2 and mu2 will become now 4 by 3. The object distance you will conclude according to V1 and the radius of curvature, now it will become minus 10. Because now this is the surface, second one. Now this is the ray coming is like this. So that now R will become minus 10. Then you have to find the final image position. So this way, when two refractions are taking place, you have to take two equations. Suppose let us just try to substitute here in this equation. See mu2 by 3 by 2 by V1. So 3 by 2 V1 minus mu1 is 4 by 3 by U 20. So that minus of minus plus this 1 by 15 will come. Just substitute. Now equal to mu2 minus mu1. So 3 by 2 minus 4 by 3. That is, so 3 by 2 minus 4 by 3. So 9 minus 8 by 6. So 1 by 6 it will become approximate. 1 by 6 it will become. Then R is 10. So it will become 1 by 60. Now 3 by 2 V1 equal to 1 by 60 minus 1 by 15. So if you calculate minus 45 by 60 into 15, 15 3s are 320. So minus 1 by 20 will become. So that V1 equal to, this is 2 tens are, so minus 30 will become. So now it is behaving like object for the second surface now. So now it is minus 30 means object side only. That means from here it will form somewhere so that this distance is V1, that is 30 actually. So now for this surface 30 plus this is 10 plus 10, 20. So that means the object distance for the second surface will become how much? Minus 50, 30 plus 20. That is also in front. So that way you have to decide properly with proper sign convention. Then you substitute in the formula again. Same what you will apply now. Mu1 first will come. Mu1 by U minus mu2 by V equal to mu1 minus mu2 by R. So this way you need to understand how to apply the sign convention and how to solve the question. So this is about like a refraction through a one single spherical surface. Now when you take a question related to convex lens. A convex lens of focal length f produces a real image 3 times the size of an object. That means magnification is 3, that is V by U. So V equal to 3 times U. So real image means the other side of the image. So if you consider U equal to like minus x, then V equal to plus 3x. Then what they are asking is the distance of the object from the lens, U value they are asking. Now our formula is 1 by V minus 1 by U equal to 1 by F. So 1 by 3x minus 1 by minus x equal to 1 by F. So if minus of minus plus, so 1 by x into 1 by 3 plus 1 is 4 by 3 equal to 1 by F. So that the x value will become cross multiply it 4F by 3. So this is the distance of object U value. If they ask the image distance, then V equal to 3 times x. Like that, the based on the lens maker's formula, they can ask question with including magnification also or without including also. Now radius of curvature of one surface of double convex lens is 3 times that of other. That means R1 is 3 times R2. So let's take R1 is R, then R2 will become minus 3R because R1 is plus, R2 is minus in case of convex lens as I mentioned. Now the focal length of the lens is 30 centimeter and the refractive index of the lens medium, that is mu2, that is 3 by 2. Then find radius of curvature. They are asking the radius of curvature. So here they did not mention what is the medium in which it is placed. So obviously you have to take the air medium itself. So 1 by F equal to, then it will become mu2 by mu1 minus 1 times 1 by R1 minus 1 by R2 equal to mu2 is 3 by 2 by 1 minus 1. Now this is 1 by R minus of minus then plus 1 by 3R. So that 1 by F equal to, this is 1 by 2 times this is 4 by 3R. So now you want radius of curvature. If you cross multiply it, then it will become 4F by, 2 to the, so 2F by 3. So 2 by 3 times F is 30. So 30 means 20 centimeter. So this way the question can be asked based on the focal length of a lens formula also. Focal length based question they can ask. Lens maker's formula they can ask. They can include the magnification also. Depending on the question, you have to understand and you have to analyze. Now one last and final question, let's see. That is, a lamp is placed 6 meters from a wall and putting a lens between the lamp and the wall at a distance of 1.2 meters from the lamp. So there is a lamp. Let's take as object. Now there is a wall like a screen. Now the lamp is placed 6 meters from the wall. This is 6 meters. And putting a lens between the lamp and this is lamp. And this is wall at a distance 1.2 meters from the lamp. Now here we are placing one lens. Now what is this distance? This is 1.2 meter now. A real image of the lamp is formed on the wall. That means here the real image is found in, this is the image distance. Now how much it will become? 6 minus 1.2, that is 4.8 meter it will become. The magnification of the image is. Now the magnification formula is V by U. So the magnification is V is 4.8 by U is 1.2. So that how much it will become? 4. So they are giving the data indirectly. They have given object distance, image distance, but not directly, indirectly. So when you understand the question and draw the diagram, then you will come to know what is object distance and what is image distance. Then you can substitute in the formula and you can do it. So this is how the questions can be asked based on the refraction through a lens. And similar kind of questions I have given as an assignment. So please just try to practice and try to understand. And there are a lot of questions in NCERT also. See, 7 questions they have given. So you can understand the importance. So please practice, and thank you all. We'll continue in the next session with the next question. Thank you.